Welcome. This lecture is a combination of two lectures from previous offerings of the course. What we're going to do is we're going to explore regularization of linear regression. Linear regression, let's recall, is we have some dependent values and they are approximately equal to a design matrix times some weights. And what we do is we create an objective function. Our objective function, which is a scalar function that has a vector argument, is we take the residual, which is the difference between the readings and the estimates, and we take the squared Euclidean norm. So this is ordinary least squares. The way we regularize it is we add some constraints, and these will be nonlinear constraints. And the first constraint that we're going to look at is we're going to say that the norm of the solution vector has to be less than or equal to some user-provided hyperparameter threshold theta. Or we might say that there's an additional constraint, which is we might say that we take the squared norm of the argument, and let's say that it's still less than or equal to some user-provided threshold. But what we'll do is we can say it can be a linear transformation. So in each of these cases, what we're doing is we're regularizing the solution. So let's get to it.